When radiation and radioactivity were first discovered, which was in the 1890s and 1900s, within a couple of years, people were thinking about, well, can these be used to cure cancer? Some of the leaders in that thinking was Marie Curie and her husband Pierre Curie. And one of Marie Curie's students, Gino Failla, came to New York City in 1916 and started our Radiological Research Center. So one of the main uses of radiation still today is radiation therapy to cure cancer. So at our center, we look for ways to improve radiation treatment. If you were unfortunate enough to get prostate cancer, the treatment that you get might well be the one that was devised in our center. We're also looking at different types of radiation to treat cancers. There is a new technique called carbon ion radiotherapy, and the hope is that will be particularly effective against some of the very hard to treat cancers, like pancreatic cancer and glioblastoma brain tumors. There are two aspects to radiation. Radiation can both cure cancer, but also low levels of radiation can actually produce cancer. So there are actually a remarkable number of scenarios, both natural and man-made, where we are exposed to low levels of radiation. One example in the medical world is CT scans. In this country, in the USA, we do about 100 million CT scans per year, and CT scans have really revolutionized medicine as it's practiced today. But what we understand much less about are the risks associated with the radiation from a CT scan. We know that the risks are small, but we don't know just how small. And that we need to know if we're to be able to balance the risks and the benefits of CT scans in an optimal way. One of the major issues in nuclear power is the possibility of an accident, and the accidents at Chernobyl and more recently at Fukushima spring very much to mind. What is not known about either of those accidents, so actually what are the health consequences of those two accidents? Just how many cancers, if any, are going to be produced by the exposure from those accidents? And again, if we're trying to balance the benefits of nuclear power in terms of future energy resources against the risks of nuclear power, we need to understand what are the risks associated with low levels of radiation. One of the roles of our center is to help the nation be prepared for a large-scale radiological terrorist event. One of the issues we face is how much radiation did people actually get after one of these events. The sorts of treatments that people need depend on how much radiation dose they actually got. So we've been working for some years on some techniques based on a finger stick of blood. And basically this is a very high-tech, robotically driven methodology for handling hundreds of thousands of samples very, very quickly to try to estimate what the radiation exposure is based on a blood sample from any of these individuals. Until a few years back, the most common type of security scanner in airports was actually a whole-body X-ray scanner. And one of the things we research quite a lot is what are the risks and benefits associated with those X-ray scanners, particularly given that many millions of people went through those scanners every year. Nowadays, those X-ray scanners have been replaced by what's called millimeter wave scanners. It's a different type of radiation, and we think a safer type of radiation.
2, 1. And liftoff.
The types of radiation that an astronaut would be exposed to on the way to Mars and actually on the Mars surface are completely different from the sorts of radiations to which we're exposed here on Earth. But you can recreate them basically using a radiation accelerator, and we do that at our center at the Radiological Research Accelerator facility. Now, surgical site infection is a real scourge in hospitals. We're particularly worried about MRSA, or MRSA as it's sometimes called, which it's proving harder and harder to deal with because it's becoming more and more resistant to the antibiotic drugs that we have. So everybody's been looking for some methodology for killing bacteria that doesn't involve antibiotics. What we've developed in our center is a type of ultraviolet radiation which both has the killing properties of normal ultraviolet light, but on the other hand is safe for human exposure. So there is a major shortage of radiation scientists in this country. And that became very apparent, for example, during the Fukushima disaster of a few years back, when the US government was looking for sources of information and there really weren't enough experts. So we feel it's our responsibility to train a new generation of radiation scientists. I think this is one of the most important things we do because we cannot lose the expertise in radiation research in this country.